In this experiment, we are going to study and verify the transfer and output characteristics of N-channel JFET using multisim simulator. So to do this, let us go to the multisim simulator. Place a JFET transistor here. So go to the place, click on component. In all families you find transistor is selected, and in that family go to the JFET N. In this JFET N, we have to consider BFW10 transistor. So here it is BFW10 JFET N channel JFET transistor, and select it and place in this working area. After placing this JFET, we will place input voltage source, which is VGS, and output voltage source, which is VDS. So go to the place, component. In all groups you find there are sources. Go to the sources, go to power source, select DC power and click on OK. Place one of the DC power source at the input side and the another voltage source at the output side. After placing this, we will be taking three different meters to measure the voltage and current. To take the component, we have to go to indicators. So here indicators are there. In this indicator, you have to consider a voltmeter. In this voltmeter, we have four different options. Voltmeter H is for horizontal direction. Voltmeter HR is horizontal but in reverse polarity. Voltmeter V is vertical direction, and voltmeter VR is vertical in the reverse polarity. So at the input side, we have to measure the voltage with negative polarity. So minus plus, therefore voltmeter VR is to be selected. So I am selecting this voltmeter VR and it is to be connected at the input side. So for time being, I am placing it at the input side. At the output side, I required a voltmeter with the positive negative sign. So I will be selecting voltmeter V and placing it at the output side. We required to measure a current, and therefore I am selecting ammeter. This ammeter is to be connected in the series arm. Therefore we have to select ammeter in the horizontal direction, and the current flowing through this ammeter would be from drain side, from power supply side to the drain side, and therefore I am taking this ammeter in reverse polarity, minus plus polarity, that is ammeter HR, and then press OK. Place this in the series arm towards the drain side, and this is the placement of your ammeter. Once we placed all those components, we have to connect it to the circuit diagram. Now for this FET, we have to given a negative gate voltage. So to change the polarity of this input voltage source, you have to click on this, right click and say flip vertically. So when you say flip vertically, negative terminal will come up and positive is connected at the bottom side, and this negative is connected to the drain gate side of the FET. So this negative terminal is connected to the gate side of the FET, while the source of the FET is connected to the ground. So this source terminal and power supply, all they are connecting to the ground. Similarly, the positive terminal of the drain voltage source is to be connected at the drain side along with this current meter, and therefore I am connecting this positive battery to the positive terminal of the ammeter. The negative terminal of the ammeter is connected to the drain side so that it will become in series to measure the current. Now the negative terminal of this V2 source is to be connected to the ground terminal. Now we have to take a ground terminal for the circuit. So to do this, go to the place, component, and go to the sources. In sources, go to the power source. In power source you find there is one last option, which is there is a third option which is ground. So take this ground terminal, press OK and place it in the circuit. Now everything is with respect to this ground, so connect this ground to the circuit. Now we have to connect this voltmeter at the input and output side. So connect this voltmeter V1 at the input side. Similarly, we have to connect the voltmeter at the output side. For understanding purpose, we are changing the name of the voltage sources. So to change the label, double click on this V1, go to the label and change the name to VGS. Press on OK. You can see the name has been changed to VGS. Similarly, at the output side, click on the V2 and change the name to VDS. So the name also has been changed at the output side, which is VDS. After doing this, we have to simulate this practical. So first we will plot the output characteristics of the circuit. To do this, go to the simulate, then analysis and simulation. In analysis and simulation, select DC sweep. In DC sweep, on the right hand side, you find analysis parameter. So first select the voltage source 1 as VDS because the output characteristics is between VDS voltage and current ID, where your VGS source is remain constant, and therefore I am selecting source 1 as VDS. Keep the start value 0 and stop value to 12 volt. So make it 12. Of increment 0.5 volt, we will keep it as it is. Now click on this checkbox of source 2 so that it will be enabled. After enabling this, select the source as VGS because for different constant value of VGS, we have to see the output characteristics. I am keeping start value 0. Keep start value is 2 volt and increment is of 0.5 volt. After doing all this setting, click on the output. In the output, we have to add current expression. So click on the add expression. In add expression, in the function, click on the absolute, double click on the absolute function, and in the double click of absolute function, inside this expression bracket, click on I of VDS. Double click on I of VDS and press OK. Once you press it on OK, this absolute value of ID current is being added in the selected variables for the analysis. After doing this, click on the run button and you can find out the output characteristics for different value of VGS. To change the background color of this graph, go to the graph option, click on black and white colors. So background color has been changed to white. If we want to change the color and thickness of all the graph lines, right click on it and click on the trace width. I am selecting trace width for 3. Similarly, for all other graph, you can select the trace width is equal to 3 so that we can easily observe these waveforms. This is our output characteristic. To change the name of these characteristics, double click on DC transfer characteristics and here you write down output characteristics of JFET. Say apply and OK, the name has been changed. Now to perform the transfer characteristics, I will close this window for time being. To perform the transfer characteristics, again you have to go to the simulate, go to the analysis and simulation. In analysis and simulation, select DC sweep. The transfer characteristics is between gate to source voltage and current ID. Therefore, I have to select source 1 as VGS. I am selecting source as VGS. Select the start value 0. Stop value is 2 volt and take increment of 0.2 fold. Now at that time your source 2 should be VDS source. So select source 2 as VDS, take its start value 2 and stop value is equal to 4, and you can take increment value of 2 fold. After doing these settings, you can click on the run button. Once you click on the run button, you find this transfer characteristic is observed. You can change the trace width of this to, let's say, 3 for both the graphs, and you can find this is our transfer characteristics. When your ID current increases, when your VGS voltage increases, your ID current starts decreasing. Double click to change the name, double click on these output characteristics and write down here transfer characteristics of JFET. You can say apply and OK. This way we perform the characteristics input and output characteristics of JFET. Thank you.